Alright, thanks for watching, and today I want to calculate a really interesting limit, namely the limit as n goes to infinity of n factorial to the 1 over n. And for this, we need the full power of the pre-ratio test, which I've proven in a previous video, but what it says is, essentially, the root test is better than the ratio test. So if you take the lim inf as n goes to infinity of the ratio terms over Sn, it's less or equal to the lim inf of the root terms, so Sn to the 1 over n, which is less or equal to the lim sup of the root terms, and that's less or equal to the lim sup of the ratio terms. So Sn plus 1 over Sn. So in some sense, the root terms are squeezed between the ratio terms, and paradoxically it shows that the root test is actually better than the ratio test. Now, why is this useful? Because notice this is of the form 1 over n, so we can actually apply this theorem to study this sequence. But first of all, because we want to write this everything in terms of 1 over n, notice that we can write this sequence as n factorial to the n to the n to the 1 over n. So which suggests to let Sn to be this middle term. So let Sn to be n factorial over n to the n. So the limit is really this term, okay? And therefore, this suggests to study the ratio terms. So so consider Sn plus 1 over Sn, which really is n plus 1 factorial over n plus 1 to the n plus 1 over n factorial to the n to the n. Lots of n's here, and then let's split this up. So this becomes n plus 1 factorial over n factorial times n to the n over n plus 1 to the n plus 1. And you'll see this simplifies very beautifully. So what do we get? Well, the n plus 1 factorial over n factorial simplifies to n plus 1. This is n to the n over, let's just write this as n plus 1 to the n times n plus 1. And notice this also cancels out. And so in the end, we're left with n over n plus 1 to the n. But now we would like to take the limit of that as n goes to infinity, so let's work a little bit harder. For instance, let's factor out n from the numerator and the denominator. So 1 plus 1 over n to the n. So this cancels out, and you're really left with 1 over 1 plus 1 over n to the n. And now, if you let n go to infinity, well, 1 stays 1, but the denominator goes to e. So actually, what do we get? We get that the limit as n goes to infinity of the ratio terms is just 1 over e. And then we'll conclude that actually the limit we started with is 1 over e, but for this we need to use the pre-ratio test. So what do we have? Here's the thing, this limit is 1 over e, so the lim sup and the lim inf are also 1 over e. So that was, I think I called it the lim sup squeeze theorem. So 1 over e, it's the lim inf as n goes to infinity of the ratio part, Sn plus 1 over Sn, which again is less or equal to the lim inf of the root part of Sn to the 1 over n, which is less or equal to the lim sup of the root part, which is less or equal to the lim sup of the ratio part. And remember, the lim sup here is the limit, and that's 1 over e. So what do we get? We get that the lim inf and the lim sup here are squeezed between 1 over e and 1 over e. So therefore, those two things must be equal. Hence, the lim inf as n goes to infinity of Sn to the 1 over n, it's the lim sup as n goes to infinity of Sn to the 1 over n, which is 1 over e. But then by what I call the lim sup squeeze theorem, this actually forces the limit of this to be 1 over e. So the limit of n factorial to the 1 over n just becomes the limit of Sn to 1 over n. Again, that's just by definition of Sn, and therefore this becomes 1 over e. And this was 1 over e. Amazing! Alright, if you like this and you want to see more math, please make sure to subscribe to my channel. Thank you very much.